So today we're talking about DeMoivre's theorem. It's the last bit to round off what your test is going to be on next week. So we're going to build on what we talked about the other day and multiply complex numbers in trig form by raising them to higher powers. It's still a part of the whole, r sine theta, r cosine theta. It's still a part of that family, so that's why we are doing it along with this particular unit. So Abraham DeMoivre is credited with discovering a useful pattern for evaluating powers of complex numbers. Okay? And if you think about it, I don't know if anybody ever thought that, the other day when we talked about multiplying complex numbers doing the product. Did you ever think about, I wonder if I could FOIL it? Okay, because technically it was set up as a binomial. You had r cosine theta plus I sine theta. You could, one of my students later on that day basically asked, well, if I forget the formula, could I just FOIL it? And no, you could not FOIL it. But DeMoivre, he is the one who's basically responsible for allowing you to quote unquote FOIL complex numbers when they're in their polar form. Okay? So say you had two complex numbers that you wanted to multiply. Clearly, guys, we already talked about this the other day. You have two complex numbers. When you're multiplying, what do you do to your r's? You multiply them. So r times r is r squared, and to your thetas you add them. Now theta plus theta is 2 theta. Okay? So basically when you multiply z squared would equal r squared times cosine 2 theta plus I sine 2 theta. Okay? But say you wanted to get z to the third. You would basically multiply z squared by z. Okay, so you're basically multiplying this equation by one of these. When you multiply, what do you do to your r's? R squared times r would be r to the third. And to your thetas, what do? So 2 theta plus theta equals 3 theta. So you have z to the third equals r to the third cosine 3 theta plus I sine 3 theta. Yes. Division, well, tomorrow's only credited for products. There is somebody who's credited for quotient, but that's not in this class. So you don't have to worry about quotient. Following the same type of pattern, do you think you could tell me what z to the fifth might possibly be? R to the fifth cosine 5 theta plus I sine 5 theta. Yep. So basically, this is the proof on how you can basically get DeMoivre's theorem. This applies to any power. Okay? This applies to any power.
So whatever the power is, you plug it into R and theta.
Maybe we could show our work stuff.
I would hope that you would show your work, just in case you mess up somewhere. I can at least give you partial for having the formula right, and you just botched the math part. So. If polar form, I missed the M here. If polar form of a complex number is z equals r cosine theta plus I sine theta, then for all positive integers n, this only applies to positive integers for n, positive powers. You have your formula, which is DeMoivre's theorem. Okay, r cosine theta plus I sine theta raised to the n, or basically apply to the n, as you saw in the proof. Okay. So anytime you're trying to do higher powers of complex numbers when they're in the polar form, you can just apply DeMoivre's theorem instead of trying to figure out, okay, well, what is this complex number times this one? Multiply it again, basically 6 times. This is kind of like a shortcut. Okay. So what we're going to do is we're going to look at 3 examples, and that'll be all for today. We'll look at 3 examples of applying DeMoivre's theorem to complex numbers. Sometimes they'll be in their complex form, their rectangular form. Some of them might be in their polar form. So like this first one. Find 4 plus 4 root 3I to the 6th power and express it in rectangular form. Okay? So hopefully you wouldn't sit there and try to do 4 plus 4 root 3I 6 times and try to multiply it. Okay? You don't want to do that. But what you can do is you can convert it to polar form, apply DeMoivre's theorem, and then convert it back to rectangular form. That would be the easiest instead of sitting there trying to FOIL that all out. 16 plus, what's 4 root 3 squared? It's gonna be 16 times 3, because when you have to square this, you're basically multiplying by itself. 4 times 4 is 16, root 3 times root 3 is 3. So 16 times 3, which is, what's 16 plus 48? What is it? Square root of 64 is? Nice number, awesome. Now we need to find theta. We find theta by?
Y,
B
tan inverse y
Or B
over
over A. What happens to those 4s? They cross out. Is there a point on the unit circle where tangent is the square root of 3?
Yes.
Yes, there is. We need to be in the what quadrant? First quadrant, since both A and B are positive, so it's going to be pi over 3. Again, for tangent, tangent's y over x, so you need the y value to be root 3 over 2,
in the top.
which is the top, and then the bottom to be 1/2. So now that you have your r and your theta, this is going to be 4, just kidding, 8 cosine pi over 3 plus I sine pi over 3. This is what we're going to raise to the 6th power. So applying DeMoivre's theorem, that is going to be, where's the 6 going? It goes in for the n. So it's going to be 8 to the 6th power cosine 6 times pi over 3 plus I sine 6 times pi over 3. What? Yep, question.
Why are you doing the one that has R to the end when it's Z equals?
Well, or
Or
Same.
you're just doing the one that's.
yeah, the one in which that how I wrote it.
Okay.
So these are basically the same thing.
It's just depending on how it turns out. So
How you end up writing in polar form, yeah. Okay. So what is 8 to the 6th?
a number that.
It is a big number.
262,140.
Can I say that a little slower?
262. 144.
And 6 times pi over 3 is 2 pi. So there is our polar form, but they want us to express it in rectangular form. So what's the cosine of 2 pi? 1. What is the sine of 2 pi? So we're going to multiply 262,144 to 1 and 0i to get. Do I have to put the 0i?
No.
If you put it, no, I'm not gonna. No. And there's the Morse theorem.
This really is.
That is what you would get if you sat there and did 4 plus 4 root 3 times 4 plus 4 root 3 times 4 plus 4 root 3 times 6 times. That's what you would get
If you did that correctly.
if you did it correctly.
Let's
If
get
you
that
did
right.
it correctly.
And if you use the calculator, if you typed it correctly, without a stop.
Exactly.
Instead of equal.
Yes.
That's stupid amount of math to do.
All right. I want you guys to try the next 2 on your own, unless there are questions. You guys have any questions?
What's the next one?
Yeah, the next 2.
Thank you, Brian.
I'll give you guys a second to write it down, and then I'm gonna go back to this so it can be up there for you, so you won't have to keep flipping back and forth.
I'll let Brian control this.
Here are the next 2. So here's what you should have got for B. R did equal to theta. That was in the first quadrant, so you need a pi over 3 to get your complex number in polar form right here. When you're raising to the 4th power, that means the 2 gets raised to the 4th power, and pi over 3 gets multiplied by 4. to get 16 cosine 4 pi over 3 plus I sine 4 pi over 3. You evaluate that to get your answer in rectangular form. Raise your hand, you got that answer? Good stuff. Alright. It says use a calculator for part C, but you really don't have to use a calculator for part C when it comes down to finding theta. It's more for the fact that you got to raise r to the 8th power. That's really the only thing you need your calculator for. So, to find r, what you guys get for r? 4. Because you would have had 2 radical 3 squared plus 2 squared, which gave you a square root of 16. So you got 4. Theta, the tan inverse of negative 2 over 2 root 3. That simplifies down to be negative 1 over root 3, which simplifies down to be negative radical 3 over 3 by rationalizing. So you're trying to figure out where does tangent equal negative root 3 over 3. Where is that? That's 11 pi over 6. You're in the 4th quadrant, so you need a value that's in the 4th quadrant. So theta is 11 pi over 6. Now, if you use the whole concept of the inverse of tangent, you could have said that was negative pi over 6. You still would have gotten the same answer in the end. So, our complex number in polar form applying DeMoivre's, we're going to raise 4 to the 8th power, right? And we're going to multiply 11 pi over 6 by 8. What is 4 to the 8th power? Slowly.
65,506. 36. Who said 3 times?
And when you multiply 8 and 11 pi over 6, what do you get?
2 pi.
What do you get? 44 pi over 3. And even though that's not on your unit circle, you can subtract a whole bunch of 2 pi's till you get a value that's on your unit circle, which is 2 pi over 3. Does anybody need to see that worked out? What is the cosine of 2 pi over 3? Negative 1/2. And the sine? So you distribute to get, what's half of this number? Plus the same number, I radical 3. Yes.
When you went to 44 pi over 3 cubic, I did the same way Terry and I did it. Instead of having minus a bunch of 2 pi's,